Welcome. In this today's video, we will be discussing on multiple linear regression analysis in SPSS. First, before analyzing multiple linear regression, first we will be analyzing relationship with scatter plots. Thereafter, we will be checking the correlations. Thirdly, we will run the multiple regression analysis. So as a first step, we will be checking relationship using scatter plots. For that, go to graphs, legacy, scatter dot, matrix scatter, and define that. You have to select all the three variables. Here we have selected y with x1 and x2. All three are there. Now we can proceed. Now we will be getting the matrix scatter, and we can analyze y and x1 and x2 relationships. It roughly indicates positive relationship, and x1 and x2 relationship is also given. This also indicates roughly positive relationship. After completing, now we will be checking correlationship among these variables. For that, go to Analyze tab, correlate by variate, select all the three variables y, x1 and x2. Then you can select correlation coefficient as Pearson. Then select two-tailed. This indicates we will be checking only whether there is a relationship or not. It does not indicate whether correlation is positive or negative. So proceed with two-tailed test and OK. Now you will be getting correlation table. Y and x1 significant, this also significant, x2, and when we check x1 and x2 relationship, here it is significant only at 10% level, and we refer Pearson correlation, that is 0.176. This is not much correlated. However, in case if Pearson correlation is above 0.9, it indicates something about multicollinearity issue. There could be. So here there is no issue. We will be proceeding with multiple linear regression now. For that, go to Analyze, Regression, Linear, and you can select dependent variable and also two independent variables. Thereafter you can select method. We have selected default value, that is enter. In this, when you are using enter method, it will be calculating and taking all the x variables and remove, and other methods sometimes includes basic model and add other x variables. First it will take the highly contributive x and thereafter other x variables, and backward it will be taking the whole model, thereafter removing others. Likewise, there are some differences in these methods. First, we will be selecting enter. Under statistics, we can select estimates and confidence intervals, just to elaborate, like B1 and B2 precisely with confidence intervals. And thereafter we will be selecting model fit R square, then collinearity diagnostics, just to check possible multi-collinearity issue. Thereafter, under residuals, we will be ticking DW test, that is for serial low autocorrelation of residuals, and case-wise diagnostics we will be selecting as it is outliers outside 3 standard deviations. And we have to keep in mind, in multiple linear regression, here also we have to satisfy some assumptions related to residuals. First, mean should be 0, then no serial low autocorrelation. Thereafter, residual distribution should be normal. Likewise, these things to be satisfied. So, we will be selecting this, thereafter continuing. Thereafter, under save, under residuals, we will be selecting unstandardized, and when we select this, we will be getting into our data sheet this unstandardized residual column, so that we can proceed tests for unstandardized residuals, whether it is normal or not normal, by using KSO SW test. For that, we will be ticking that. If you wish, you can select distances like Mahalanobis and influencer statistics. Otherwise, just leave it alone and press continue and press OK. Now you will be getting the output. In that, first look at model summary. Here you have to refer adjusted R square, adjusted for degrees of freedom. This indicates 26.2% of variance of Y is being explained by x1 and x2 variables. Thereafter, we have to refer Durbin-Watson for auto or serial correlation. Now it's somewhere around 2%, so auto correlation will not be an issue. Next, we will be referring to ANOVA table. F statistic is significant, meaning at least one of the x's describe Y variable. So when we refer coefficients, we can see whether x1 or x2 or both are explaining Y. Here when we refer coefficient table, both x1 and x2 are significant, meaning those two are explaining Y variable. So when we consider x1, 1 point increase in x1 contributes to 0.408 increase of Y, and similarly 1 point increase in x2 increase Y by 0.354. So finally we will be referring significant of this x1 and x2 t-test significant is also witnessed by lower and upper bounds, as those are in positive level only, does not cross 0. And when we refer collinearity statistics for possible multi-collinearity issue, VIF, that is not greater than 5, that means there is no VI multi-collinearity issue, and tolerance, that is not less than 0.2, so there is no multi-collinearity issue. Thereafter we will be referring to residuals. As we said, there are assumptions in multiple linear regression stating residual mean should be 0. Here the mean is 0, and next thing we will be referring to is standard predicted value. These should be within plus or minus 3, so it is also satisfied. And now we will be checking distribution normality of residuals. Here, as per this one, chart and graph along with the line indicating normality, and here also disperse all over, so indicating normal distribution. However, now we are going to ascertain it by case and SW tests. So when we refer to data view or variable view, you will be noticing the newly added unstandardized residual variable. So we'll be checking normality. For that, analyze, descriptive, explore, then select newly added unstandardized residual and press OK. You will be getting this table, descriptive table, along with test for normality. Both the case and SW tests are not significant, meaning residuals distributed normally. So that is being satisfied, indicating non-significant, and that indicates normal distribution of residuals. So even the histogram, stem and leaf, and these QQ plots indicate the normality or normal distribution of residual. With that, we will be concluding today's multiple linear regression tutorial. And just to summarize, these are the 3 steps of MLR. First, check the relationship with scatter plots. Second, determine the correlation and specifically check correlations of X's. If it is more than 0.9, there could be possible multi-correlated issue. Third step, just run the multiple linear regression analysis. With that, we will be concluding. Thanks for watching.